Hello, everyone. This is Dr. Sri Banerjee, Dr. B, and in this lecture, I will be going over some basic tenets of epidemiology. But before I go over any sort of lecturing on epidemiology, I will be going over some basic calculations which will allow you to understand not only this discipline, but also allow you to further delineate what types of measures are appropriate for understanding the pandemic. So, without much further ado, let's go ahead and get started. Let's start off by talking about the founding father of modern epidemiology, Jon Snow. Now, you might be wondering, Jon Snow, is this the person that is pictured on the top, or do you think it's the person pictured on the bottom? If you guessed it was the picture on the top, then you were correct. The picture on the bottom is from the Game of Thrones. His name was Jon Snow as well, but unfortunately, he was known for conquering dragons and not founding epidemiology. So the picture in the middle, it's a very important picture. This is a depiction of London from the 1800s. And this was the first time that scientists came together and were trying to determine what is causing a cholera pandemic, a cholera epidemic within the city. And so what Jon Snow did is he systematically studied all of the different wells, and the Broad Street well was actually a common pump, a common well from which a lot of the city got their drinking water from. So what is important to note here is the location of the wells in comparison to the spread of cholera, the infection. And you can see there is a direct connection between the location of the pump and the cholera, location of cholera infections. Similarly, this sort of investigation, this sort of case investigation takes place all across the country and all over the world. Say there is a food outbreak that came from your local grocery store. Maybe the spinach was recalled, or maybe a couple of people got sick from the ice cream. Whatever it is, foodborne illnesses, novel pandemics, all of these are fair game for epidemiology. So, when I first got my introduction to epidemiology, this was kind of the route that I took in learning and understanding some of these concepts. My background is, of course, in medicine. And so when I transferred and tried to shift gears from medicine into public health and then also to epidemiology, it was somewhat of a culture shock for me because I was so used to looking at certain aspects of disease from an individual level and treating the patient that you sometimes lost sight of the fact that there was actually environmental factors. There's actually social factors that may be going on that might be influencing the health outcomes of the individual. So systems-based thinking, transitioning from individual thinking, patient-centered thinking to systems based. And when I mean systems based, of course, I not only mean by cardiovascular system, renal system, but also systems based, I mean looking at it at a societal level. So social ecological model, thinking about Bronfenbrenner, people like that. So anyway, this is kind of what epidemiology is all about. And if you take a look at some of these study types and the evidence needed, this is now talking about COVID. And since while we're taking this course, while all of you are taking this course, we have a pandemic which is out of control in our country. And so there's still certain elements of this disease which are not completely known, since as a medical community, we haven't really had enough exposure to the virus to know exactly what it entails. But if we wanted to gather and collect more information, then what are some of the types of studies that need to be held? And what evidence would you have to look at in order to conduct the study that is listed? So, just at a basic level, if you're taking a look at just the number of cases, right, including milder ones, then syndromic surveillance can really play a major role in doing that. However, that would have to be complemented with viral testing. And one of the problems, one of the frustrations that public health officials have faced since the beginning of the pandemic is the unwillingness to ramp up testing, COVID testing. Increased testing would mean that the general population would have more accurate information, and based on this, contact tracing can take place, and this can stop chains of transmission. However, when all of this was manifested and all of this was implemented, a lot of case definitions, things like that, were not being tracked as accurately as we initially would have liked to have accurately tracked. So anyway, you can go through this list, and one of the other ones that I would like to bring to your attention is the attack rate, and also timing, infectiousness timing and intensity. This is something of an unknown. There's such a long incubation period for the coronavirus, for COVID-19, that a lot of times there's a pre-symptomatic period when the person is infectious but asymptomatic. And as it turns out, about 40% or so do not exhibit any symptoms at all. So this allows for the spread to take place a lot more. And then, to make matters worse, another level of complication that has been recently added is the fact that there are multiple variants that are appearing of the original virus, which means that there are mutations that have taken place since then. And that makes the whole world nervous due to the fact that even though current mutations don't indicate that they would be they would be resistant to any vaccine, but if there's too many mutations, then the vaccine may not be efficacious in the context of too many mutations. So for now, these are the measures that need to be paid attention to. So now what I'm going to go over here is this website called 19 and Me. And this is interesting because it utilizes one of the risk scoring tools that we have at our disposal. And this risk scoring system actually provides a nice comparison, not only with other diseases, but specifically influenza. And early on, there were these reports of individuals making claims that this is no worse than the influenza virus. However, if you actually do a comparison, as of now, in the last flu season, there were actually only any number of deaths is a lot, but in comparison to COVID-19, there were 35,000 deaths of flu. In comparison, COVID-19, within a matter of about 10 months, had taken the lives of about 400,000 individuals. So putting that into perspective, this is a much more severe virus, and this will allow you to accurately give a depiction of how risky, how likely it is that you'll get the virus. So here I go over the mechanism of action, and one of the main things that takes place, of course, is the the attachment to ACE2 receptors, angiotensin converting enzyme to receptors. So upregulation of activity of these receptors allows for the entrance of the virus particle within the cell. And not only that, it allows for the sabotaging of receptors so that the virus can effectively hijack the cell system and replicate millions of copies of its own. And as the days goes by, and more and more and more copies of this virus develops within the human body. Okay, so this is kind of another way to present this information. These are the predominant organs: lungs, heart, kidneys, intestines, brain, and testicles. These are the main places that the ACE2 receptors are expressed. As it turns out, the virus can also cross the blood-brain barrier as well. So this is a more detailed depiction of how COVID-19 enters the human body. And for those of you that may not really know or may not remember, COVID-19 stands for Coronavirus Disease 2019. So again, this is an RNA virus, and you can see how once the viral particle is attached to the cell membrane within the cells, the RNA dependent RNA polymerase goes in and starts coding for the viral particle, for the COVID-19 viral particle. And then once the viral particles are assembled within the cell, the virus is using the apparatus of the cell in order to produce more particles, more viral particles, and take over. But that's not the whole story. That's not everything that is going on. Yes, it's true. Viruses are taking place, taking over, and trying to create havoc within the body. But our own body, our own immune system, the inflammation that is coming out of that is also contributing to the severity of the disease. So a lot of times the inflammatory reaction that is taking place to the virus, it has no off button. So it's ramped up, it increases, it's overexpressed, and that's what causes a lot of the cavitation and a lot of the damage which is taking place within the lung, eventually resulting in something called acute respiratory distress syndrome. This is a whiteout within the lung, which you see, and unfortunately that leads to death from there. So there's different drug cocktails that are being used, but not really used as frequently as it should be. So this provides a good overview of not only the field of epidemiology, but the application of epidemiology and investigating diseases, investigating infectious diseases. But this also can apply to chronic diseases as well, like diabetes, obesity, hypertension, everything else. So keep a broad mind, keep an open mind, and be ready to learn. There's a lot of different sub-disciplines, subgroups under epidemiology. Thank you for listening to this lecture, and if you have any questions, please do not hesitate to contact me. Thank you.